Hello. Well, as you may know, I do audio and video transfers, and today we're going to be looking at a piece of equipment. It's a professional machine. It's a Kramer 4046 standards converter, and in looking at this we'll also get to play with some other machines along the way. Now, okay, so what does this do? It's an analog TV standards converter. So fundamentally it can do things like NTSC to PAL and PAL to NTSC. But it does not include a digital time-based corrector, so it is just for the standards conversion. You can get other devices that do include a time-based corrector, and I've got some. But also you can get ones that are perhaps a little bit less aimed at the professional market, but actually they do really the same job. And this was a popular product. Cost around about £250 for the basic model. So it's a GTH Electronics ACE converter. This is like the Mark II version that includes a time-based corrector and some various proc amp, process amp adjustments, and also standards conversion, NTSC, PAL and CCAM. So it's a very capable unit actually, and I've got a fleet of about 10 of these. And I had the manufacturer provide me with a special firmware for the way I like them to be set up. The reason I'm going to be playing with this Kramer one today is somebody wants to buy it off me. Actually, one of my competitors. And the problem he was having was that his NTSC VHS machine had died. And of course, you could always play an NTSC VHS tape on a PAL machine. And if you plug it into a TV, it'll give you a picture, generally speaking. And I'll demonstrate that in a moment. So we have an NTSC tape here, and I have a PAL video recorder here, and we'll demonstrate that. But the problem is that it doesn't output NTSC or PAL in that mode. It outputs NTSC 4.43, and what that means is you get NTSC line and frame rates with the PAL color signal. This is not to be confused with a strange variant of PAL called PAL M, which was used in Brazil or somewhere. It has different specifications. The problem with NTSC 4.43 is when you capture it, your capture device may not understand it. Here's a typical good quality capture device. So it's the Canopus ADVC-55, and it has inputs for stereo sound and composite or S-video inputs. And it outputs FireWire. So you get a DV stream from this, which you can capture on a computer that has a FireWire input. It'll give you files of 13 gigabytes per hour, which are fairly high quality. That's the same codec as used in professional DV cam tapes. Much higher quality than you can get from these horrible little capture devices that plug in through a USB port. Now, I'm not saying that this is necessarily suitable for every application. For things like digital Betacam, I generate much larger files from SDI video signals, digital video signals. But for the vast majority of case users, this kind of capture device is what's required. Now, the problem being, if you feed that with NTSC 4.43, what you get is a black and white picture. You need to give it a real NTSC or PAL signal. So you'd need something like a standards converter to accept NTSC 4.43 and output pure NTSC. Then this can be configured for pure NTSC. Actually, that first switch there in that up position there, that means it's set for PAL. Push it down, now it'll capture in pure NTSC. What you don't want to do is convert the line and frame rates unless you really have to, because most of these standards converters will impart some movement imperfections when you switch from 50 to 60 or back frame rates. And that includes this as well. The results, if you change from NTSC to PAL or back, not great. But what it can do a great job of is NTSC 4.43 in and pure NTSC out. And looking at this, we see that for the input standard, it does include NTSC 4.43, so we should be able to do exactly the same trick here. NTSC 4.43 in, and then pure NTSC out. And look, this does include PAL M, which is the slightly oddball variant. Right, what we're going to do first is demonstrate here this Super VHS machine, which I took as a trade-in. It's an NV-FS100, so it's one of the older models, and that's a Super VHS video recorder, so it's decent quality, and I'm going to feed that into a TV via composite, and let's just see if we get a good colour picture from PAL and NTSC tapes initially, and then we'll have a play with the standard converters. Right, we're just going to connect this up via composite video. This is not a model I've ever actually had a play with before. What's this switch? Test, on, off, and comb filter. Comb filter. Switchable comb filter. And this switches the SCART signal from being composite out to YC out, so that effectively acts as another S-video output signal if you need it. Right, we're going to just use composite video just because we're hooking it up to a TV, just to confirm it all works. Okay, so this video recorder I took as a trade-in, so I don't know anything about it. I only hope it works. Let's have a play with it. Okay. There's a remote control with it too. Does that work? Not yet. Oh, yeah, the remote does work. Any kind of picture? Oh, yeah. Just turn that down. Yes, that seems to work quite well. Oh, it's him. Huh. Oh, I don't like him. Let's eject him. That's some tape that came in the machine. Oh, throw him away. Right, so here we have old NTSC recording. This TV, I'm assuming, will accept that input and give us a colour picture. That's not going as well as I'd hoped. Well, I may have assumed that this machine would do NTSC playback, but maybe it doesn't, so I'll have to go and find a machine that does. Since we last spoke, I've taken the trouble to understand the operation of this machine a little bit more. Front panel input standards lights don't operate when you're in colour bar mode, so the colour bar is just a dip switch at the back. Why you'd want that at the back and not the front, I don't know. So we can switch that off. It has also an automatic selector for the video standard, but the automatic doesn't detect NTSC 4.43. So for that to happen to work, you need to set it manually with these dip switches. So now we're in, we force this NTSC 4.43 mode. Input is composite video, output is NTSC. So the thing about this device is that it cannot convert from NTSC to PAL. The line and frame rate have to stay the same. Okay, it should now work as a NTSC 4.43 to real NTSC decoder. Let's give it a whirl with some random video recorder. Happens to be a DVD as well. Any menus or anything could be output in PAL and it won't understand them. There we go. So that's fair enough. Let's just put in the NTSC tape. Hit play. Oh, it's gone into play. And that's not working, is it? We don't have any colour. So this NTSC 4.43 does not appear to be working properly on this setup. That's disappointing. Let's try another one of these. NTSC 4.43, output NTSC. That should work. Still black and white. How disappointing is that? Let me show you what should have happened. This is a much more capable unit actually than that professional machine over there, because this includes a digital time-based corrector and a full standards converter, so it'll do NTSC to PAL, albeit it does it in a basic way with dropped frames, so motion doesn't look very good. But here we're going to have this input the NTSC 4.43 and output pure NTSC with this particular combination of buttons I've just pressed. So let's see if that works. Press play. And now we have a full colour picture. Exactly what we were looking for. And because it's going from 60 frames per second to 60 frames per second, we're not getting any motion artifacts that you would get if you switched over to PAL. Good. This works a treat, but they are very hard to get. I have a number of them, but they are very hard to get. So I'm afraid all we can take away from this is these professional units from Kramer. Not really that good. Let's have a look at what's inside this and also what's inside this one. I've worked on these a bit. I've had to replace components in these occasionally. Actually, they're pretty reliable. There's more than one version of these, but we'll have a look at what this particular one has. There's a lot of information on the web anyway from the manufacturer. Let's start with the Kramer. Well, there's an IC from Analog Devices, ADV-7194 KSTZ, professional HDV NTSC PAL encoder IC. There's an XC3S200, which is a field programmable gate array. A Texas Instruments TVP-5146 4x10-bit digital video decoder, which kind of implies that there should be analog to digital and digital to analog, and I don't know why it can't do NTSC to PAL. I'm not quite sure where that functionality is missing. There's no memory, I guess, but surely, having come this far, it wouldn't have been that hard to do it. It does seem odd that they've built something that looks like it has the potential to do so much, but actually achieves so little. I must be misunderstanding what the purpose of this device is, because as far as I can tell, it's more about changing your signals than it is about changing the TV standard. So yes, it will convert from something that's like NTSC to something else that's like NTSC, except it doesn't seem to work for us. And presumably it can do something with PAL too, like it could go from CCAM to PAL, presumably. But that's not what it's fundamentally about. I think it's more about the fact that it'll accept something like YUV and output something else. So, for example, I could use this. I have a particular machine which I usually capture, not always, but usually capture S-video from an M2 format machine, but it's only got YUV output, so I could feed YUV into this and go S-video out. The other way of doing it is to capture YUV, and I have a system for that. But that's the sort of application you could give it. I don't think it's terribly useful. Oh well. That's not to say I dislike everything Kramer have done, because I use some Kramer firewire switch ports, and I find them absolutely brilliant. Let's have a poke about in this unit. Okay, so this is all based around Xilinx Spartan as well. The firmware is on a controller in there. This one's marked up F. I've got different firmware in most of my units. So that says copyright GTH Electronics year 2000. This one's version 3. There's another version of this that looks virtually identical but has some different controls. But it is not a Timebase corrector. It's PAL only. So it's nowhere near as useful as this version. So I've had an IC fail on one of these before. I think it was that one that had to be replaced. Now there is a bit of a failing of these things. It's only quite slight, but there is, even when you go, for example, PAL to PAL, there's a small loss of vertical resolution. And I've never fully understood quite what the reasoning is behind that. It's very slight, and I've tried really hard to see it, and eventually I was able to just about detect it, but it is very slight. And for any normal work, such as VHS or beta, it really isn't a problem. These give more than they take away, so they're very useful for video transfers. Just a bit difficult to get hold of, and they were always fairly expensive. They started at £250. Not a huge fan of the case design. Looking at the back here, as well as a power input, which it has its own onboard regulator anyway, so it shouldn't be too fussy about that. It takes audio in and out, and you might say, well, why? It's because when you press fade on this, it can fade the audio as well as the picture. It's got RGB and audio out as well, so that can go up to your monitor, which is ideal. S-video out, which is typically what I would use. I'd have that connected to something like the S-video in on the Canopus device. This selects composite or S-video input there. Then on the front, on this one, we can adjust, so a little proc amp there, we can adjust picture a bit. A very nice feature this is you can change where the color registration is relative to the luma. On formats such as VHS, the chroma drops by one line. Press that and you can bring it up several times. Every time you press the button it goes up. And you can also shift the color side to side. And I very often find on something like VHS or beta, setting will be about there, so that chroma and luma line up properly. You can alter the input and output standard, so it'll accept PAL in that mode, NTSC in that mode, CCAM in that mode. You've got color bars, you can output in different standards, you can fade. Sharpness I rarely use, but I have used it on occasion. Certain pneumatic tapes suffer from ringing, and actually with a certain setting of this it's possible to, about there, tune out the ringing. You go too far, the ringing comes back, which is very weird. So the way it does the sharpness control is obviously quite complex to do with the way filters work, and if you ever look up how filter design is a very complex thing. So it's not as simple as when you turn the sharpness down it just reduces the bandwidth. It doesn't, it's more complex than that. So that can be used for tuning out ringing on pneumatic at the expense of some resolution, but still you generally get a better picture for your trouble. This digitizer, that's an awful thing. I can't see the point of that. I hate it. I wish there was another control there that was more useful. You can also alter the red, green, blue balance, but this also Acts as a hue control for when you've got a hue shift. This one has different firmware, and some of the features are that by default when you switch it on, it locks out CCAM and NTSC 4.43, and that can be useful if you're playing tapes that have a lot of glitches on them. It can sometimes trigger the CCAM detection. So by having it off by default, you can avoid that. You can achieve ignoring it on here by, on this one, you power it up and hold that button and ignore CCAM and NTSC 4.43. On this one, you power it up and hold that button and it'll enable NTSC and 4.43. Then there's a freeze frame, very occasionally use that, and 3200K. What that'll do is allow you to correct color balance on occasions when somebody's used made a shot outdoors with their camera white balance set for indoors. That just press that button and it can look a whole heap better in one go. So they're my go-to time-based correctors for domestic work, but for professional work I have some others. Here's one I've shown you before. I think it's particularly useful, I find, for U-matic, because it will take dub signal and allow us to convert that to S-video. And here's another time-based corrector I've bought. This one I could replace with a Kramer units, I suppose, because it's primarily used for my M2 machine, which already includes a digital time-based corrector, and it's used to go from YUV to S-video. This particular one came from the police because it had a police logo programmed into it, and I had some fun setting up a serial port so I could change that and put my own logo on it instead. Yet another time-based corrector I have is a monstrous thing, which is intended for use with my 1-inch C format Ampex video recorder. But that time-based corrector got damaged in transit, so that's a bit of a project. Well, hope you've enjoyed looking at some of these time-based correctors and similar devices. Next, please join me for unboxing and setting up a real professional Amscope microscope system, which I've just bought in. All the parts have just arrived today, so I'll be getting straight on with that right after I've shot this video. Please remember to like, share, and especially subscribe, and I'll do a lot more content on audio and video technology in the near future. Bye for now.